Okay, in this video we're going to talk about the definition of the derivative. Um, so, just say the derivative. Okay, now the derivative is a concept in calculus, and one of the things that it tells us is slopes of tangent lines. So given a graph, and I'll just sort of sketch one here, a tangent line is a line which touches at one point and does not cross the graph at that point. It just touches it. Okay, so this is what we call tangent. Now, the idea here is kind of an old one. So if you have a circle, Greek mathematics concerned itself with, amongst other things, what does it mean to have a tangent line to that circle? But for us, we can think of, well, what would it mean to have a tangent to any function's graph at any point? And the derivative will tell us in an algebraic way how to compute that. And that's something that we'll talk about more in class. For now, we just kind of want to get a rough idea as to what do these slopes look like so that we can test whether or not the answers that we'll get algebraically are reasonable. Okay, so what I've pasted in here are four graphs of four different functions. And I'm not going to tell you what the actual formula for these functions are. That's actually not all that important. Okay, so for each of these graphs, there are two sort of special points drawn here. And then you can see that there are these blue lines. So the blue lines are all tangent at a given point. So this blue line here is tangent at this point, and this blue line there is tangent to that point, and so on for the other four graphs. Okay, so what we're asked to do here is to estimate, oops, I want the curves. We want to estimate the slope of these lines, and it's just going to be eyeballing it from the graph, so nothing nothing too fancy for right now. So just estimate the slope of the tangents. Okay, so let's take this first one here because it's actually pretty straightforward. This first blue line, okay, so this is, say, we'll do function 1a. The line appears to be horizontal, so we should expect slope to equal 0 because that's what horizontal lines have. Okay. Now, if we look at the blue line and we compute it, pick, say, some other point on it, so I'll put these in red so they're a little bit more visible. So this point, the given one, we need to stick with. And if we pick some other point over here, then the slope is rise over run, and we see that these two points have the same y-coordinate, and hence delta y would be 0. The x-coordinates in this case are 3 apart, so but it doesn't matter because we still get 0. Okay, so in fact we do get this about the slope that we expected. All right, now for 1b, well, here the slope looks like it's a positive number of some sort. And maybe if you just eyeball it, positive 2 seems, roughly speaking, correct. 2, 3, somewhere in there. But it's not like 500, and it's definitely not negative. Okay, so this is a little hard to see the little tick marks here. It'll be a little more clear in your WebAssign problems. So I noticed that we go through this point right here, which is at a grid line, and this point right here, which is also at a grid line. And they look like it's 3 units up and 1 unit over. So if we compute delta y over delta x, it looked like I went 3 units up and 1 unit over, and so we should expect that the slope of that blue line is approximately 3. And that's close enough for government work. Okay, now the other 3 graphs rather, are sort of the same idea, just different looking curves, different looking lines, and so let's just kind of talk big picture what's different about them. So what's different here is that this first line has a positive slope and the second line has a negative slope. And you can eyeball from the tick marks about what those numbers are. Not too horrible. And similarly for 2a, we got one positive slope, the other negative slope. Now something interesting happens here in 2b. Namely, it appears that these two blue lines are parallel. So if you compute their slopes, you should end up getting the same number because they look like they're parallel. And you'll see whether or not that's the case when you actually do the computation. Okay, so pretty quick, pretty easy. All you need to do for the pre-class is just look at the graphs that are given, and they'll look kind of like this, and figure out what the slopes of the lines are through the given points, and just eyeball as best you can. The answers are all integers, so there's no like crazy decimals or anything like that. Just to kind of get a big picture as to how to eyeball what the slope of these things are. Now, this is great if you're given a graph and these points are sort of nice points on the graph. What we'll do in class, and what we'll continue with for quite a while after that, is what about if I don't give you a graph? What about if I give you a function instead with actual formulas and algebra? How would we compute all of this stuff then? So that's what we'll talk about in class. See you then.